Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey folks, welcome to Making Data Simple. As always, glad that you're here. It's Friday for me. I know we usually release these on Wednesday. It's Friday, and here's the good news. Today, I am going to go visit my daughter in college. She doesn't know it yet. And she's having a party this evening. So the last thing she wants is her parents to come visit her during her party. I'm sure of it, but that's why you do it, right? You probably want me to get on to business, so I'll do it. So today we're going to talk about data. We're going to talk about startups. I have Barr Moses with us as a guest. You're going to love today. CEO and co-founder of Monte Carlo, a data reliability company, data observability platform. It's backed by Excel. It's backed by Redpoint. There's many other Salesforce ventures. I could go on. Previously, she was VP of customer operations at Gainsight, where she scaled that company 10x in revenue. She's also been a management consultant at Bain & Company and a research assistant at the statistics department at Stanford University. And she also served in the Israeli Air Force as a commander of Intelligence Data Analyst Unit. Graduated from Stanford with a BSc in mathematical and computer computational science. Look, folks, Barr might have just a little bit of ambition. All right, Barr, I am already intimidated. I appreciate you being here. Thank you. Please introduce yourself further in anything that I may have missed.
Thanks so much for having me. It's great to be here. I'm excited to chat. Excited for your Friday and your weekend as well. I'm Barr, CEO and co-founder of Monte Carlo. Our mission is to accelerate the adoption of data, to help organizations accelerate the adoption of data by reducing what we call data downtime, which is basically periods of time when data is wrong or inaccurate or otherwise erroneous. And it's actually a problem that's honestly been around for a couple of decades, but has accelerated in its importance. The stakes are way higher today for data and for data to actually be accurate. And so it's a way bigger problem today. And as a company, we're fortunate to work with some amazing industry-leading data teams, including folks like Affirm, JetBlue, CNN, Fox, and many others.
You've got a pretty interesting resume. Israeli Air Force as a commander of intelligence. That's where it all kind of started with data, or was it earlier than that?
Yeah, so I was born and raised in Israel, in a small town in the suburbs of Tel Aviv, and was drafted to the Israeli Air Force, as are most folks who are 18 years old, drafted to the Israeli military. Worked, this was, more than a decade ago. So, how we work with data was very different. I think the concept of data science didn't quite exist back then. But the importance of using data that's accurate and that's reliable, I think has been around during my time there as well. And so as part of my job, I was leading teams to analyze data, to make decisions based on data, and to make recommendations based on data for operations in the field. And so at a very early age, learned about, kind of the work that's required in order to deliver high integrity data. I sort of learned this term later on in my career called zero defect data. And the idea is, can you deliver something that's, really has an aspiring to have zero problems in it? It's actually really hard to do that. I don't think I've heard anyone say today, our data is 100% accurate or 100% reliable. Anyone in data can tell you that that's not really possible, but I think we can get better compared to where we're at today.
Well, that's why, I've got this podcast called Making Data Simple.
Yeah.
We have a lot of different people on it, and sometimes I have my business coach, different things. But I've left it at Making Data Simple, one, because we've already got the following, but two, everything surrounds data. So it looks like you use service to your advantage in the Israeli Air Force. Is that where you began your interest in data?
Yeah, it's definitely sort of the beginning of both my career and my interest in data, as well as my interest in actually like building and working with great teams. One of the things that was really unique about that time is that, you're you're very young, and you don't have sort of a decade of experience going into your job, right? So I was 18 years old at the time, working with largely 18 and 19-year-old, and yet the responsibility that you have is quite significant, right? Especially sort of in that context of the Israeli military. And so, you at a very young age have a lot of responsibility. There's a lot at stake. And also, there's a lot, I was a commander of a team. And so there's a lot to learn about how do you actually motivate people in that situation? And how do you, work together to achieve a better outcome? And all of that, again, at a young age, being away from home, you can go home probably like once a month or so to see your family. And so you learn a lot through that, and that was definitely kind of the start of my my career and my interest.
So then you went to Bain. You were a research assistant. You went to Gainsight. I'm just curious, any learnings that you had from your VP of customer operations while you were there?
Yeah, definitely. So, I was really fortunate to join Gainsight sort of in the early days of category creation. So this was, think about this at the beginning of the category. Actually, customer success was not something that was well understood. Today, folks are like, yeah, of course you need customer success. But back then, it wasn't quite the case, right? And a lot of that has to do with the change from sort of one-time purchase to recurring revenue and the subscription model, right? With the rise of subscription and sort of recurring revenue, you actually have to earn your customers' trust and earn your customers' business every single day. And that's a big shift that's happened, obviously, in the last decade. And as part of that, this methodology around customer success and customer support has really, sort of changed dramatically. And so I think in the early days, it was sort of like, I'll buy from you if you'll buy from me. And this is very much like a relationship-based business. And, let me take you out to dinner and we'll like sign the deal and move on, right? And today, in today's business, companies face the problem of, hey, every single day, I need to earn my customers' business and trust because they need to renew every single year. And how do I do that in a data-driven way, right? How do I actually prove value and ROI? And a lot of, what folks turn to is actually trying to, in the context of customer success, is actually turning to data to prevent and predict churn. So the question of, how can I tell that a customer is about to churn? What are the telltales in the data? What can I learn? And there's some things, that some sort of metrics that folks look at specific, what I would call kind of leading indicators of customer health. So NPS being one of them, right? So NPS has become a lot more prevalent today. NPS is basically net promoter score. It's a question where you ask your customer 0 to 10, how would you recommend to a peer or colleague? And there's obviously different benchmarks for what NPS could look like, but that's sort of common standard to look at. And then there's sort of more surprising things that the data can tell you. So, for example, I remember doing sort of an analysis of our customer and signals for churn. And we actually learned that behavior around support tickets is very indicative of churn. So for example, if someone has very many support tickets, like way too many of them, that could be a sign that a customer is really struggling, right? That there's just too many support tickets and things are not working. However, the interesting thing was also a lack of support tickets. Like if there's literally no support tickets for the last period of time, that's also a sign of danger because that basically means that there's zero engagement. So there's basically like a happy medium of a certain number of support tickets that tells you that the customer is engaged enough and actually seeing value, but not completely inundated with sort of bugs and issues like that. And so there's actually, I think companies have become a lot more sophisticated in how they think about indicators of churn and how they use data around NPS, support tickets, engagement with webinars, engagement with the brand, engagement with the website, many other indicators that you can use in order to inform your view on the health of customers.
I'm glad I asked you that question because I come from a support heritage, having held a position very similar to what you described in IBM, and I think we're kindred spirits. The support is very interesting. It's a wealth of knowledge with the tickets, and whether you have no support tickets, you're absolutely spot on. In fact, some of the time, it depends on if it's the right kind of tickets. However, the busier you are, the clients calling support about things that are working or not working, whatever, a direct correlation to how well the business is doing. I think you said something that's pretty profound. It doesn't seem profound on the surface, and that is you got to earn business these days. And I think this, and I don't know if you agree, but I think a large part of that is given the social environment that we're in today, customers can be very well educated, all the resources they have at their disposal. You've got to be a challenger seller to be able to come in and teach, tailor, and take control, or else, what differentiates you? It's got to be the product. It's got to be something that you're able to offer them that they can't find out for themselves. Where before, you're right, it was all based on relationships. The world's completely changed from that perspective. I think selling has changed from that perspective. You agree?
100%. I think there's a complete change of not just selling, but also delivering value. And I think the bar is a lot higher. So, just thinking through the customer journey all the way through marketing, when a sort of lead engages with your brand, through sales, when actually a person is interested in solving a problem through your product, to engaging as a customer, to actually using your product and then renewing your product. That entire journey has just taken a whole step up in terms of what we need to deliver. So, people today, the way that they engage with brands and acquire, honestly, let's put ourselves in their shoes for a second, right? First of all, they are inundated with vendors who are clamoring for their business, right? There's like so much, and in data in particular, there's this explosion of vendors, an explosion of options. So, the number one thing that many of our customers tell me is like, there's so much stuff. And if I'm starting to build a data platform, where do I even get started, right? Or if I want to build a certification process for specific data assets, so I know which data assets to trust and which I can't, where do I get started, right? That's probably the number one question that I have. So vendors data leaders or data people are inundated with vendors. They also don't have time. So they can't afford to wait, 9 to 12 months to have the product implemented. They have to deliver results yesterday. There's a lot more sort of scrutiny on data teams today. Data teams are no longer kind of like hidden in a side part of the business. In the past, a decade ago, there were only maybe a handful of people in data. They were looking at the data once a quarter when they were reporting numbers to the street, and that's it. Today, you have data platform teams that are like hundreds of people. There's data engineers, data product managers, data analysts, data scientists, ML engineers. The list is long, right? There's so many people. And so the stakes are higher and the demands are higher. And so as a leader of that function, you definitely cannot wait a long time to see ROI on your investments. So, I think as a result of these things, the way in which we've been selling and buying software has changed. First of all, you cannot, implementation cannot be 9 to 12 months. It has to be, minutes or hours or days at most. At Monte Carlo, we aspire to deploy in minutes actually and start seeing value immediately. And customers want to know and have a lot more questions about ROI, right? And understand like what kind of time or money are you saving for me? And first and foremost, like customers care about solving their problems. And I think, you move from being a vendor to a partner when you're actually able to solve a meaningful problem and partner with them and help them, help your customers actually see what other customers are doing and how other customers have moved along their data maturity journey, where they are relative to that and how they can progress on that. And that's a very different relationship than when it was a few years ago.
Thank you for that. So let's dive into Monte Carlo. I'm going to start very easy. Why the name Monte Carlo? Seems like a betting and gambling and a James Bond flick right now.
Yeah, there's a lot in there. And, I think primarily, what we focus on at Monte Carlo is sort of this category that we're calling data observability, right? I'll talk a little bit more about that. In terms of the names itself, I mentioned I sort of did research at the stats department at Stanford, worked with some Monte Carlo simulations. That's kind of the origins of the name. On the betting side, I think you don't want to bet on bad data.
Good call.
Can be the tagline there. But generally, I mentioned kind of spearheading this category called data observability. I think kind of going back to your comments that you kind of read through, this problem of data quality has been around for a while, right? So folks kind of asking themselves, hey, is the data wrong? Is the data wrong? Why are the numbers in the report looking weird? That has been around for a really, really long time. What's changed is that now there's sort of you can take a new approach that's based on concepts in software engineering. That's a lot of what we're focused on in Monte Carlo, is taking, not trying to reinvent the wheel, but actually taking things that work well in other industries and applying them to data. And I think that has been easier to do in the last couple of years as there's been standardization on tech stack. Answered more than your question about why the name Monte Carlo.
That's okay. That's good. I mean, but say more on that name of Monte Carlo, because I think it's got a fundamental basis of what you're talking about. I mean, Monte Carlo is usually some kind of prediction of the outcomes. You can run a simulation. I mean, are you talking AI there, or are you saying no, that's not? No, here's what we're doing.
Yeah. So Monte Carlo it's basically a way to predict an outcome in a specific situation when you actually don't have sort of a closed analytical model of the problem. And so instead, we try to simulate the problem many, many times over and over again and use that to try to predict what the outcome could be. The best example that I like to use for this is, predicting the outcome of an upcoming election. There's no kind of, closed form analytical model of election prediction. But one of the cool things that 538 actually does, if you're familiar with that website, is that they run 40,000 simulations of potential outcomes in different states using different data sets. And by looking at those collective results, they're actually able to predict the overall outcome of the election. So that's kind of, just to explain sort of what Monte Carlo simulations are with an example. At Monte Carlo in particular, some of the reasons why we named the company that way. One is, again, sort of that's sort of, our kind of background in data. The other answer, to be honest, we didn't have a lot of time to come up with a name. We just got started working with customers really quickly, and we needed to come up with something. And so, I sort of opened my stats book and sort of went through the names, and I think Monte Carlo sort of stood out to me from my earlier work before then. I think for folks kind of in the data space, it's also a name that's familiar. And that's it. I sort of fell in love with the name, and we went from there. But I always tell my team, if anyone can come up with a better name, let me know. I'm all ears.
There's a lot of problems in there to resolve around data. In other words, we talked about cleansing. Yeah. Right? I think you said earlier, or you alluded to the fact that you're only as good as the data that you have. So there's cleansing. There's insights around the data. There's transforming. There's moving data. What problem is Monte Carlo specifically? Where do you start and end? And what are you specifically resolving in your technology?
Great question. So let me explain what data observability means. And I'll start by actually using a corollary and using the concept of observability in software engineering. So in software engineering, the concept of observability is basically understanding the health of a system by looking at its outputs. And what does that mean? Very familiar with folks. Let's take, a website. Let's say if a website is down, then that's downtime of that particular website. And there's someone on the engineering side who's making sure that the website is up and running at all times. And so there's specific methodologies and tools, solutions that have helped engineers make sure that their application and infrastructure are running at all times. However, in today's world, many of those applications might be down as a result of bad data. So I'll give you an example. Netflix was down in 2016 for 45 minutes because of bad data. There's actually duplicate data that resulted in Netflix being down. And so in those instances, the traditional ways of making sure that applications are up and running are no longer sufficient. Now you need to figure out whether the data that's powering your applications are actually accurate and reliable. 45 minutes of Netflix being down is a long time.
For my kids, that's like travesty. That's
exactly. It's like eternity, right? Let's take another example. Let's take an example of a marketplace that prices houses, right? Let's say the data that they're using for a particular house is wrong. You might be underpricing or overpricing a particular house based on wrong data. obviously the implications of that are material in terms of revenue for your business. This wasn't the case, a decade ago. A decade ago, we weren't using data to power the products that we're using today. Let's take another example. One of our, we have many customers in media. They power events like the Super Bowl and the elections and sort of other events that they cover. They are able to use data to make decisions in real time around how many devices you're using, and do you have enough bandwidth to use to actually see that. And so in real time, they can adapt your experience to make your experience better in viewing those events, as an example, and improving the quality of their coverage. And so all of this is to say, making sure that your data is reliable and accurate is analogous to making sure that your applications and infrastructure are up and running. And so the concept of data observability is exactly that. It's taking the best practices from DevOps, concepts of observability, and applying that to data. And so companies are starting to get into measuring data downtime or data uptime. And imagine a world where you have 5 nines of data availability, right? So we always talk about 99.99% uptime of applications. What would it take in order to make sure that you have 99.99% uptime of your data? What does that look like? That's what data teams are starting to think about. Now that is very different from cleansing data, right? And so if you think about what a solution like AppDynamics or Splunk or Datadog does, sort of kind of as a third-party layer, making sure that those applications are reliable. In the same way, data observability solutions connect as a third-party layer to your data stack. So let's say your data lake, data warehouse, ETL, orchestration, BI solution, ML models. There's no sort of ingestion or processing of the data, but rather there is observing the data, collecting data about the data, if you will, inferring the health of the data based on that, and letting you know as soon as data breaks. So for example, let's take a particular example. Let's say your company is running marketing campaigns and relying on data from Facebook that sort of comes in regularly, or some other sort of third-party data. And let's say that data hasn't arrived today, and it arrives every single day for the last 3 months, except on weekends. But today it hasn't arrived. Today is Friday, so it should be arriving. In that case, you probably want to know about that. And so is there a way to automatically learn that the data gets updated every single day, except on weekends, and that today it was supposed to get updated, but it's not? Can you automate that process? And can you actually help data teams do that in a way that doesn't require manual intervention? And that at the end of the day, what data observability is, it's sort of an organization's ability to understand the health of your data. And it actually impacts sort of, the entire stack. So it's not like a sort of a point solution, if you will, but rather it's important to think about that as sort of an end-to-end concept, all the way from ingestion of data to consumption of data by data analysts, data scientists, and business units as well.
Got it. Understanding and observing the health of a system. Does it instrument correction?
Great question. So most solutions also in software engineering as well actually are not involved in the correction of issues. They're sort of focused on 3 core areas. The first is detection. So actually allowing teams to be the first to know about problems. So, to give you an example, if there might be, going back to the marketplace that's, has house prices. Let's say, there's a problem with the data and you're underpricing or overpricing a house. How long is that issue happening before you catch it? For some companies, it might take months or even a full year to identify that problem. And you might be losing millions of dollars as a result of that. And so the first thing that folks look at is detection. How quickly can you find out about those issues? The second is resolution. So often data teams, once there's a problem, they spend a lot of time actually trying to replay the data or correct the data, or actually just understand what the root cause is. And so time to resolution is the second big focus area. And then the third is actually prevention of these issues to begin with. So what we found is that if you kind of instill these best practices of data observability, you're actually able to reduce the number of occurrences of data going wrong to begin with by introducing this sort of a higher degree of diligence, if you will, from day one. One of our customers, Fox, actually, they have a pretty sizable data team, and their VP data there sort of calls it controlled freedom, which I really like that term. It's sort of allowing people in the company to use data freely and actually make decisions based on data, but in a controlled way that ensures that the data is actually accurate and that they're using data that's trusted in order to make those decisions.
And like if Monte Carlo, we're talking about the product you offer, is it involved with all three, or just the observation and the detection phase?
So we think that the concept of data observability and data reliability, a strong solution for that should incorporate all three. And so at Monte Carlo, we are building a product that's focused around that. I think I'll give you an example for why. One, if you're able to detect something, but you don't quite understand what the implications of it, it might just become noise. So, for example, let's say the data from Facebook or some other third-party data has not arrived today, in a particular table, but nobody's using that table. So who cares? maybe it's fine that the data hasn't arrived on time. Maybe it's fine that data never arrives. Maybe I don't need to know about that. But actually being able to have the right solutions in your disposal to say this data is broken and it's really important because it's driving decisions that this person is making on a daily basis is really, really important. And so I think, the part sort of around anomaly detection as part of the first part of that life cycle, if you will, it's a very important component, but that's just where the story begins. And where we find, kind of teams that are really thinking about this as a way of operationalizing trust in data and are able to reduce, north of 70 to 80% of their data incidents, is by adopting that mindset. And again, it goes back to software engineering teams, right? Like engineering teams, you would be crazy to be building an engineering team and not have, a full process where you detect a problem, you get notified on it with PagerDuty, you assign sort of a team or a person to resolve it. You might do a post-mortem after that in order to learn and to prevent the next issue. You might be looking at the specific source of the problem and see if there might be correlated issues to that. All that good stuff that engineers do, data teams need to start doing as well. And so it does, I think, require thinking through those three parts holistically.
I'm still unclear though. How do you get from the detection to the resolution and prevention? In other words, let me state while you're thinking about your answer here. On the detection or the anomaly detection, I think people get that. But then the question is, how do you distinguish when you're observing good behavior versus bad behavior?
Yeah, so by and large, I don't think that the goal is to have zero human intervention, right? I don't think that's the case. I do think there's some business context that people will always know, and our goal is not to fully eliminate that. I think what ends up happening today is that most teams spend about 99% or let me say 80% of issues are caught by hearing from someone downstream. So someone downstream is saying, hey, the report here is wrong, or hey, the numbers here don't make sense. And then there's a small percentage of issues that are caught by writing manual tests. So I can specify, hey, this particular table needs to get updated every 2 hours. And if it's not, let me know. Or I expect 1,000 rows here. And if I get more or less, let me know, for example. That's by and large what the reality is today for teams. I think there's a better way to do this in which actually 80% of that work is automated, meaning, we can, using machine learning models and sort of other techniques, we can actually sort of forecast or anticipate what sort of the behavior patterns are and let you know when those are violated. And on top of that, we can let you specify sort of custom-based rules for your business. So if, for example, there's a particular table that, someone is looking at or depending on at 6:15 a.m. and that the data needs to be right by 5:50 a.m. It's a true story. Then, you can specify that in particular. That's something that a machine or me, I could never guess that. So I think there's definitely a part that will always include manual intervention. But I do think there's a lot more automation that we can introduce. Just to give you a little bit of kind of color on this, 5-7 years ago, and when we were doing this, we actually had to sort of manually draw a lineage on a whiteboard. Like we just got up and like literally manually map that out. And today we can actually infer a lot of that, which is really sort of groundbreaking for many data teams.
Well, look, I think the question is it the magic or the brilliance in determining the questions that you didn't even think to ask? Well, I think that's where you find, when you find anomalies and you're asking questions that you're like, hey, look, I didn't even know this was in the vicinity and it's costing me money.
Yeah, it's exact. So I think that's exactly right. There's sort of two components to it. One is actually the manual work that takes into writing the known issues, right? That's a not insignificant amount of work for data teams. And then on top of that, there's the unknown unknowns, right? Mm-hmm. The things that we don't know, we can't write a test for. I'm not going to know that's going to break. Can we automate that? Can we learn based on observing your system? I think that's exactly right.
So how does duplicate data bring Netflix down?
Great question. I actually highly recommend watching a talk about this. So there's a talk, if you Google Netflix 2016 down for duplicate data, there's a full talk that they did about what happened and a whole initiative that they actually spun as a result of that in order to address this. So actually, I highly recommend watching the talk.
Would Monte Carlo have prevented that?
I don't know the intricacies of sort of Netflix particular setup, so I'm not gonna commit here, but I can tell you that our product does, we can actually like track and look at instances like that. But I'd probably have to learn more.
No, I get it. So what use cases are you targeting? Under X, Y, or Z, these are perfect use cases for Monte Carlo.
Yeah. I'll go a little bit broad, and I'll generally say a little in a broad sense. If you have a data platform and you have a data warehouse and a BI solution, or if you're using data and there's high stakes data in your company, and you don't have a data observability solution, whether it be at Monte Carlo or something else, you're doing something wrong. It has to be a core part of any data organization today, or any company that's taking data seriously has to have some rigor around the trust in their data. You really have to be crazy to be flying blind. It's actually crazy to me that we didn't have anything like this before. That's at a very high level. So if you probably want to make sure that the data and everything that you've invested in that is actually accurate. That's sort of, kind of at a sort of fundamental level. More specific on the use cases, the number one thing that we hear from folks are, hey, we're trying to use this data, but there's a lot of people that are complaining that the data is wrong. So a particular number in the report looks weird, or everything is suddenly a null value and I'm not sure why. Basically, folks in your company, in your organization, who want to use data, who rely on data, and the data is often wrong, and the data team is not the first to catch it. That's sort of kind of like the next the next specification. In particular, I'll talk a little bit about when we say data observability, what do we mean? Data can go wrong for many different reasons, right? There's like thousands of different reasons. It could be, an engineer introduced a bug, or someone made a change somewhere, or someone made a semantic change, or there's really sort of thousands of different reasons. And so it's actually, at the onset, it's actually not obvious that there's sort of a pattern and that there's something common here. And actually, before starting Monte Carlo, we spoke to several hundred data organizations and asked them, tell me all the reasons why data was wrong, and tell me all the sort of symptoms that you saw in order to catch that problem. And then tell me all the things that you did in order to resolve that. And so we actually built a database, or kind of a collection of stories, if you will, and use that to formulate what we think, sort of consists of a strong approach to data observability. And there's sort of like 5 pillars to data observability that we found consistent across those. The first is the freshness of data. So we actually talked a little bit about this, but making sure that your data actually arrives on time. And so, for folks listening, if it happens that you rely on thousands or hundreds of data sources, and sometimes the data doesn't arrive, you probably want sort of automated way to know that. So that's one pillar. The second pillar is around volume. So again, we talked about this a lot, but sometimes, sort of expect a consistent level of or volume of data to come in every day or every hour. And the data has actually arrived, the job is complete, but it's only half the data that you expected. That's a problem. The third pillar is distribution, which is really sort of at the field level. So that could be things like duplicate values or null values, or, taking an easy example, let's say you're collecting credit card numbers and suddenly you have a letter in that field, right? That's an example of something that is probably an issue. The fourth pillar is schema changes. So oftentimes folks make schema changes that impact data downstream. And then finally, the fifth pillar, which is probably the most controversial, if you will, is actually lineage. So data quality solutions in the past traditionally mostly focused on kind of the data quality elements, if you will. And we actually think that lineage, both field level and table level lineage, is an important part of understanding the health of your data, exactly because of the reasons that we talked about earlier around understanding both the downstream implications of something going wrong. So if a particular table is late, who cares if there's no one relying on it? And also understanding the root cause of issues. Freshness, volume, schema, distribution, and lineage.
Can you also explain the concept of building data like a product?
Yeah, for sure. So, several years ago, what was data? It was really, a couple of Excel files and a couple of folks, in a small part of the organization. And data was confined to a very small number of teams and a very small number of use cases. For example, reporting numbers to the street, sort of give that as an easy example. It's funny, even today, I would say actually the number one use case for companies is just counting revenue or just counting customers. So in a way, like we've progressed, but we actually haven't progressed that much, right? Our fundamental questions around data actually stayed the same. Just there's a lot more of it to collect in order to answer that. But if you think about today's world, there's data engineers, data scientists, data analysts who are all using data in different domains and different areas. And they're using data for different use cases. So for example, they can be using data for a specific report that, your CEO is using to make decision based on churn, or your support team is using for churn. Used that example earlier today. Another example is, your product team may be using, or your engineering team may be using data to power a specific machine learning model, a recommendation system. And then, the list of examples can go on, but basically the idea is that different teams use data in order to produce different types of data products, if you will. And there's this kind of new way of thinking around, can we introduce some of the concepts from product and engineering and treat data with the same rigor? Again, this goes back to sort of using ideas from software engineering here. And so there's this rise of this new role, which is a data product manager. And product managers, kind of in my opinion, they sort of play the role of the liaison between sort of the customers and what the customers need, and translating that into what to build in the product as a result. And so a data product manager actually does that, sort of acts as a voice, on behalf of customers in your organization, and helping the data team form, what kind of data products do your customers need? What kind of data do they need? What kind of data should they use? How to clean it? What data not to use? And sort of helps kind of, direct specifications and requirements for empowering more people in the organization to use data. So it's this sort of, at a summary, I would say this kind of a new way of thinking about data in organizations, and one that matches the needs of organizations today, where there's more data, more sources, and more people using data.
The time has really went by extremely fast. And I'll try to wrap up very quickly because I want to be respectful of your time. What does Monte Carlo do differently than everybody else? What's your differentiation?
Yeah, great question. I mean, we're sort of fortunate to be kind of at the forefront of this new category, data observability. I think it's a super interesting time for data in general. and for data observability in particular. I think, at the end of the day, just to come full circle here, the thing that's most differentiating for us, obviously, talked a little bit about what I think makes for a great data observability product. But in the end, you shouldn't believe us. You should ask our customers. So, mentioned many of them: CNN, Affirm, JetBlue, Fox, many others. You should really sort of turn to our customers and ask them.
Now, are these listed on your website, or is there a place that the audience can go review this information?
Yeah, feel free to visit our website, montecarlodata.com, or hit me up on LinkedIn, Barr Moses. I'm super happy to chat and answer any questions. It's my favorite part of my day.
Anything that I didn't ask you that you wanted me to ask that would make it complete, or did I get it all?
No, I think you got it all. Yeah, this was a pretty thorough hour.
Great. Thank you for this. I got one last question, and then I will let you go. What do you do for fun?
Great question. I have a 1-year-old daughter. Her name is Ray, and I have a lot of fun with her. I also love hiking. I think in California we're really fortunate that we can be in nature, so I love hiking and meditation.
So a CEO in a startup, woman in technology with a 1-year-old daughter. You must be able to do it all. That sounds quite challenging. And
I have a great team. I have a great team, both at home and in Monte Carlo.
Sounds good. So, and could you say the website one more time, please?
MonteCarloData.com.
Okay. Thank you so much for being here. I appreciate it. Listeners, thank you for being here. Hit us on almartintalksdata@gmail.com. We'd love to listen to your thoughts. Rate us anywhere you listen to our podcast. And until next time, we'll see you.